All right, in this example, we're going to turn the tables a little bit and work with the stress transformation equations in a different kind of way. Again, ultimately, it's going to turn out to be the case that more circle is an easier way to do this problem. But right now, we're just focused on the stress transformation equations and working with them. This time, what we're going to be given is what the principal stresses are, what the max shear stresses are, and the angles to those principal planes, right? So the sigma 1, the largest principal stress, is 19.79 KSI in tension, and the second one is 6.29 KSI, also in tension. Max shear stress is 6.71 KSI. Now, the angles to those are 121.7 and 32.7 degrees for the principals. There's a problem here, and that is that these two principals have to be at 90 degrees apart. And what you see as given information is that they are not. They're close. They're basically 89 degrees apart. So one of these two is wrong. I no longer recall which one is the correct one. So what we're going to do is decree that this second one is the one that is wrong, right? And so that has to be then 31.7, because again, those two have to be 90 degrees apart, right? So with that corrected information, then these two numbers and those two are consistent. One thing that we need to also double check eventually is to see if that's going to be consistent information. And we'll have a way that we can play with that and begin to figure out. Now in this example, we're not going to go through all the numerical details. We're going to set up the answers and then allow you to try to begin to work with it. So we'll talk about how to brainstorm through how the heck do we do this sort of reverse problem. Here are the maximums now. What the heck do we do with all those? All right, so where that's going to start from is the expression that has our principal stresses and the angles to those planes, because that's the four basic pieces of information that we've been given. All right, we got sigma x plus sigma y over 2 plus or minus all this stuff over here. And then this expression down there, and then there's your tau max expression. Notice there's really three pieces of information we're trying to figure out. Sigma x, sigma y, tau xy. We're going to need all this kind of information to be able, basically we got to have three simultaneous equations to get three unknowns. So note what happens here. And that is, we can actually simplify this a little bit. If this really is the tau max value in your problem statement, it says tau sub a, which again I think is just a long ago typographical mistake. It really should have been tau max. But notice the tau max is a function of these three things that we want. Sigma 1, 2, well, we can actually get with the plus or minus value here, you know, we've actually got more equations than we probably really need. But notice something really interesting. And that is tau max is the square root of sigma x minus sigma y over 2, and then quantity squared plus the square of tau xy, right? Well, we see that same expression right here. And this first one is really just the algebraic average between sigma x and sigma y. So these principal ones are really, principal stresses are sigma average plus or minus the maximum shear stress. Right? That's a much easier way to remember what this big long thing is, right? Wow, that's a lot easier. And if we know this value here, which supposedly we do, and we can think about the sigma average, well, we know these two, so we can play around, find the sigma average, and we can, wow, there's something we can play with, and that gives us something here. And since we know the angles as well, we can figure this out. There's enough information here that we can figure out what's going on without having to do maybe too much work. But it looks to me like, you know, ultimately we've got three equations. To solve that symbolically would be to invert it, so to speak. Is possible, but it looks like it could be difficult and a pain to do. I think if we just the fact that we start thinking about in these terms, we can find some other simpler ways to play around with what how to go from this state over to those, right? I could be wrong, but take a look, see if that will work. And again, keep in mind, is that really right or not? But we don't have information about the angle of it. So I think we've got to think that that's right. But we can play around, again, we can play around here. We've got multiple answers. There's things going on here. By the way, we actually do know where theta S is. I'll let, again, we weren't given it to us, but we can find it just by definition of various things. So I'll let you think about that. All right, so again, I'll set that up for you, some ways to think about it, and a great exercise to go through and see if you can. It is a little bit of just a manipulation, but in that manipulation, if you think through what's really happening, you'll get a lot more out of this, and it'll be much more powerful, just like beginning to think about this in this kind of way and how we can work with this to see what's going on. Now, again, when we get to the more circle, there's a whole nother approach that will in some ways be more direct, but it won't reveal this underlying more fundamental thing that starts to pop up quite as much. But there are multiple techniques for doing this sort of reverse engineering kind of approach.